Alright, y'all, today we are going to talk about transformations. Alright, so first of all, super quick, what even is a transformation? So we've looked at lots of types of functions so far this semester. For example, one that hopefully we're getting pretty familiar with is a regular old quadratic, right? This is kind of the graph, f of x equals x squared. But there are lots of other quadratics, right? There are quadratics that look like this, and there are quadratics that look like this, and there are quadratics that look like this. So these are all clearly at least somewhat related, but exactly how we haven't really talked about yet. And that's what a transformation is. So these graphs are all transformations of a quadratic. So let's talk about how we can transform a graph. We want to talk about the graphical component of transformations and also the symbolic component of transformations. Okay, so I would like to start with the basic function here, this guy. It's going to look like this and this. This guy is a cubic function, right? X cubed. But we've restricted its domain, right? So this guy, we're going to let him be between -2 and 2. So we're only looking at the x values between -2 and 2. So what are a couple of the points here? Well, let's see. These are the big ones. So this guy, right, is clearly 0, 0. And that makes sense, right? Because if we are looking at f of 0, right, if we plug in 0 for x, we get 0 cubed, which is just 0 times 0 times 0. And that's 0. If we look at this guy, this is 1. If I plug in 1 for x here, I've got 1 cubed, which is 1 times 1 times 1, which is just 1. All right, so this is the point 1, 1, and this is the point, so 2, we plug in 2, we get 2 cubed, which is what? 2 times 2 times 2, which is 8. So we have the point 2, 8. Similarly here, we've got -1, the x value -1. -1 cubed is 3 negatives together, gives us a negative, so we have -1, -1. And similarly here, we have -2, -2 times -2 times -2 is -8. All right, so let's look at some transformations of this guy. All right, so let's say we're looking at g of x. This is f. And g of x is f of x plus 2. So remember, f of x from before, we said f of x is x cubed. And this time we're adding 2 to it, right? I've just simply replaced f of x with something that it's equal to. So we have x cubed plus 2. Well, let's go ahead and look at it. So if I look at an individual x value, let's say I'm looking at -2. At x equals -2, my output, f of x, or x cubed, is -2 cubed, which is -8. But now we need to add 2 to it. So we add 2, we move it up just a smidge, and it's right there. Similarly for -1, our output is -1 cubed, which is -1. We add 2, we are here. At 0, 0 cubed is 0, plus 2 is 2. 1 cubed is 1, plus 2 is 3. And 2 cubed is 8, plus 2 is 10. So this is where we're at. We connect all of these dots. And this is G. So what has happened to G? Well, it looks like it's just shifted up. Okay, let's check out what happens when we subtract some stuff. Again, our graph starts looking kind of like this. H of x, this is going to be f of x minus 3 this time. So x cubed minus 3. I'm just going to do these 3 points just to save time. But so we're looking at this guy. Our output of -2 for f of -2 is -8. -8 minus 3 gives us -11, which is going to be like here-ish probably. X equals 0 is going to give us f of 0, which is 0, minus 3, which is -3. And f of 2, which is 2 cubed, which is 8, minus 3 gives us 5. We connect all these together. Ooh, it's kind of ugly. Sorry, y'all. Not the best at drawing. We have shifted down here. Right? Same shape, but just shifted down. So it looks like adding and subtracting just takes the whole thing as it is and moves it around, right? Shifts it up or shifts it down. If it's positive, we've shifted up. If it's negative, we've shifted down. So let's let j of x be 2f of x this time. So this is 2x cubed. So we've got our first point, which is -2, -8. When x is -2, we've got -8, right? And then 2 times -8 gives us -16. So if this is 8, then we need to make it twice as large in the negative direction. So we're about here. Similarly, here we've got -1. We've got -1 cubed times 2. -1 cubed is -1. -1 times 2 is -2. So we're about here. 0 cubed is 0. Times 2 is still 0, right? So this guy is actually staying right here. 1 cubed is 1. Times 2 is 2. So we're about here. If this is 1 on the y-axis, then we are about twice as tall. And similarly here we've got x equals 2. Our output is 8, right? X cubed is 8. And so 2 cubed is 8 times 2 is 16. So we want to be, again, about here, which is twice as tall. So our new graph, we connect those lines, or those dots. This is J. this part of the function has stretched up and this part of the function has stretched down. So it looks like we've sort of just taken the function and stretched it away from the x-axis. Let's look at what happens when we multiply by something small. So let's make, this is going to be k of x. Let's make k of x 1/2 f of x. So 1/2 x cubed. Here, if I've got my output of -8, we know that our new y value is going to be half of -8. So 4, -4. Here at -1, it's about right there, let's say. At -1, my output is -1. And my new output, we want that to be half of -1, so -1/2. Here at the point +1, +1, our old output was +1 cubed, which was just 1. Now we're dividing by half, so we are at 0.5. And then here, again, we started at 8, and we are taking half of that, right? So we're at 4. So when I connect these guys, that's what I'm looking at. What's going on here? It looks like we've kind of squished our graph, right? We are squishing the graph towards the x-axis. Right? The y values are half of what they were before. Over here in our last function, we also multiplied, but we multiplied by 2. And here, the y values are twice what they were before. All right, one more individual example, and then we'll try some mixed together. All right, so we've got, I'm going to call this m of x. And m of x is going to be negative f of x. Oh, sorry, so this is f and this is k. This is f, right, or negative x cubed. So before, at x equals -2, our output is -8, right? X cubed when x is -2 is -8. And now it's asking for -8, which is +8, right? So here. At 1, our output is -1, but now we're multiplying by negative, so we have +1. At +1, right, we have, if x equals +1, we have 1 cubed, which is 1, times -1, which is -1. And then at 2, 2 cubed is 8, times -1 is -8. So we connect these dots. And what has happened here? It's a little bit difficult to tell, but we have flipped, right? This is a flip over the x-axis. So this guy has flipped up here. And this part has flipped over here. So we've flipped to get this new function m. Okay, so let's put some of these together. Let's say we wanted to look at a new function n of x, which would look like -2 f of x plus 3. So again, we want to replace f of x with what it was before. Before it was just x cubed. So now we have negative 2x cubed plus 3. That's a lot of stuff to do, but I think we can do it. I think it'll be no problem. So our original graph was this guy. We have our few kind of important points that we know. And let's go ahead and just start putting them on the graph. So if we start with negative 2, so we know that negative 2 cubed is negative 8, right? Negative 8 times negative 2 is positive 16, right? Positive 16, so we're like up here. But we're not done. We still want to add 3. So positive 16, it's like here-ish. And we're adding 3, so we're actually pretty far up here. Negative 1. Negative 1 cubed is still negative 1. Negative 1 times negative 2 is positive 2. And positive 2 plus 3 is 5. So we're about right here. 5-ish. 0, 0, where is this point going to go? Well, 0, 0, we know we cube 0, we get 0. 0 times negative 2 is still 0. But we do get to add 3, so we end up being about right here. Positive 1, 1, where does that guy move? Well, 1 cubed is 1. 1 times negative 2 is negative 2. And negative 2 plus 3 is positive 1. So that guy actually doesn't move at all, which is kind of cool. Last but not least, we have 2, 8. Where does this point go? Well, 2 cubed is 8. 8 times negative 2 is negative 16, which is going to be like down here, right? But we're adding 3, so we move up a little bit. So let's make sure we're in line there. Okay, and we connect these points, and our graph ends up looking like this. So let's think through what has happened to this graph. This graph has clearly been flipped, right, because of this negative. It has also been stretched because of this 2, right? I'm going to write this stuff down. So we have flipped. We have also, from the negative, we've also stretched from the times 2. And we have also shifted up. From the plus 3. Well, we've shifted here, right? These guys are both shifts. Right here we're shifting up, here we're shifting down. This guy is a stretch, right? This has been stretched. This guy has been kind of squished, but we're not going to call it squished. We're going to call it compressed. So this is a compression. and this guy is a flip. What do all of these have in common? We have always been only moving up and down, right? Here when we're shifting, we're moving up and down without changing anything else about the graph. Here we're stretching up and down, right? Here we're squishing up and down, and here we're flipping, right? All of these have in common that they are vertical transformations. So all of these are vertical transformations. What do these all have in common algebraically? Here, we were adding on the outside and subtracting on the outside. Here, we were multiplying on the outside for the rest of them. All of these algebraically are changing the function on the outside, right? We are changing f of x. So algebraically changing the function on the outside changes the graph vertically. Okay, so let's look at a couple of horizontal transformations now. I've gone ahead and drawn a few of these f of x functions so that we can just kind of breeze through. If you want to take a second and draw these for yourself, maybe pause the video. Okay, so this time I want to look at what happens when we multiply, add, subtract things inside of the function. So now let's say we've got some new function g of x, and it is f of x plus 2. Okay, so this is interesting, right? So before we had plus 2 or minus 3 or whatever, all of that stuff was happening on the outside. Now we have plus 2 on the inside here. So how does that change things? Well, let's check it out. So let's see what happens at g of negative 2. At g of negative 2, then we have f of negative 2 plus 2. What's going on here? So we've got f of negative 2 plus 2, which gives me f of 0. So instead of using the output value from negative 2 like we were doing last time, we're actually using the output value of f of 0. So now at negative 2, the function g has an output of 0. What happens at g of 0? At g of 0, we've got f of 0 plus 2, which is f of 2. So our output value at g of 0 is f of 2. F of 2 is 8. So at 0, now our output is 8. Wow, so we've kind of run out of function, right? So what's going on? Well, let's think about what's going on at negative 1. At negative 1, we're going to have to look at the output value that's 2 in front of it, right? We're going to look at x plus 2, which is 1, right? So this x value moves over here. And similarly, if we kind of back it up a little bit, we're going to end up having this point here, right, at negative 3. G of negative 3 is going to be f of negative 3 plus 2, which is f of negative 1. f of negative 1 is negative 1. So we have negative 1 here. And g of negative 4 is going to be f of negative 4 plus 2, which is f of negative 2. F of negative 2 is negative 8. So we have the output negative 8 here. So our graph ends up looking like this. We have shifted. It feels a little bit complicated, but we've shifted here to the left. Now, is that what we thought it would do? Right, we have changed the x values, so it does sort of make sense that we're moving left and right horizontally, moving horizontally. But, right, we're adding, so wouldn't we think that we would be moving in the right direction? Right? Adding x, moving more positively in the x direction is to the right, correct? So, kind of confusing that we're moving to the left. But when you think about it, it sort of makes sense because here we're sort of saying, I want to look at the output of the function 2x values ahead of where I am right now. And then we're sort of bringing it backwards to the left. I don't know if that makes sense. Maybe it's easier for you to just remember, hey, when I add on the inside, we shift left. That's totally fine. But we do need to remember it somehow. So if it helps you to think about this, great. If it doesn't, don't worry about it. When we look at, let's say, h of x equals f of x minus 3, the opposite is going to happen, and we're going to actually end up shifting to the right. So our graph will look like this. This is h. Okay, what happens when we multiply? So we've got j of x is f of 2x here. So we saw before how shifting to the left and right is sort of the opposite of what we think is going to happen. Similarly with multiplying, it's going to be sort of the opposite. When we multiply by 2, we're going to end up sort of multiplying our x values by 1/2. So here we have the same y value, but my x value before it was 2, now it's 1. Same y value of 1 before we had the x value of 1, now we have the x value of 1/2. 0 stays the same. Similarly here, we've got a y value of negative 8 before the x was negative 2. Now it's negative 1. Here we have a y value of negative 1 before the x value was 1. Now the x value is 1/2. So we are compressing the x values. This is a horizontal compression. And these guys were shifts. Okay, what happens when we multiply by, let's say, maybe 1/3 even? Well, if we compressed when we multiplied by something that was greater than 1, then we're actually going to stretch when we multiply by something that's less than 1. So, for instance, right here we have the point 2, 8. when we stretch, when we have our vertical stretch, we're going to have the point 6, 8, right? The y values stay the same, but the x values are being stretched. Here we had the point -2, -8. Now we're going to have the point -6, -8. So we've been stretched horizontally. All right, last but not least, f of -x. So before we were flipping our y values, now we're going to be flipping our x values. So this guy, right, +2, +8, is going to become -2, +8. Similarly, before, this guy was -2, -8. This guy's going to become, again, we're flipping the x value. This guy's going to become +2, -8. Zero, 0, we flip that x value. -0 is still 0, so we still have the point 0, 0, and we connect these guys. Ends up looking like this. So this time we've flipped this way. We've flipped over the y-axis. This again is a flip. So I want us to notice that even though the graph of f of -x looks very similar to the graph of -f of x, it didn't have to be that way, right? It only turned out that way because this is a very symmetric graph. But if we had a graph that was less symmetric, it might not necessarily be the same. Okay, before we move on, let's think about what is happening here graphically. Before, all of our transformations had changed the graph vertically, right? It had only affected the y values. Here, all of these transformations have left the y values the same, right? But changed the x values, and we've moved left to right. So these are all horizontal transformations. And like last time, we can make the statement that algebraically changing the function on the inside changes the graph horizontally. And another way we can say this is that outside changes y values, and inside changes x values. Okay, so let's do one that does both. Let's say we're given the function n of x, and n of x is negative f of 1/2 x plus 3. So how are we going to do this? Well, all we have to do is follow PEMDAS, follow the order of operations. PEMDAS, if you don't remember, is that old saying that you may have heard before, please excuse my dear Aunt Sally. Lots of people like to remember it using the mnemonic device, please excuse my dear Aunt Sally. When I used to tutor the football players at NC State, they used to like to say, please excuse my dope, word that I'm not going to say, swag, to remember it. You can use whatever you want, whatever's helpful. Let's refresh on what this represents. Remember, P stands for parentheses, right? Anything inside of the parentheses comes first. Then we do exponents, then multiplication, division, addition, and subtraction. So, here, what is our first thing going to be? Definitely the parentheses, right? So, inside of the parentheses, we have this multiplication, so we have to do that first. Okay, so here we have 1/2 on the inside. What did we say that multiplying by a number that's less than 1 does on the inside? Well, stuff on the inside does kind of the opposite of what we think it's going to do. So we would think that 1/2 would shrink our x values, but it's actually going to stretch them. So we want our x values to be about twice as wide as they were before. So that looks like this approximately. We are definitely not done yet. That's just step 1. So step 1 here. We did the stuff inside of the parentheses first. Now we move outside of the parentheses. We don't have any exponents. So next we want to multiply. Looks like we have to multiply by a -1 on the outside. So this is number 2. Multiplying by a negative on the outside is going to change our x or y values. Our y values, right? So we want to flip our y values here. So if I have a y value of -8 here, I need it to be positive, so we're going to be right here. And if I have a y value of +8 here, we want to have a y value of -8 for that x value. So step 2 of our graph looks like this. Kind of looks like a spider. So that's step 2. And now, last but not least, we have addition. This is number 3. Addition on the outside. On the outside, it's very intuitive. +3 just means that we're taking our y values and shifting the graph up by 3. So we've got 1, 2, 3. This point, 1, 2, 3. And this point, 1, 2, 3. All right. Now that is all of the transformations, so I'm going to make that a solid line so we know that that's our final answer. I know this looks kind of messy, but hopefully it makes some sense. So this guy is our final answer. It has been horizontally stretched by 2. It's been flipped over the x-axis, right? It's been vertically flipped, and it's also been shifted up by 3. So let's make note here. When we have multiple transformations, we always follow the order of operations, or PEMDAS. Okay, that's all I have for you today. Hopefully the Desmos is really helpful with this topic. And please feel free to post any questions in the discussion forum. Otherwise, I'll talk to y'all soon. Thanks, y'all.